Now that we know what complex numbers are, we're interested in this imaginary unit I, and I'm going to show you something kind of interesting about powers of I. Alright, so first of all, I'm going to try to evaluate these powers. I squared, I cubed, I to the fourth, and let's go ahead and do I to the fifth. Okay, now I to the first power, there's not really much we can do. That's simply I. But I squared we know something about because we know that's I times I, and don't forget that means the square root of negative 1 times the square root of negative 1. So I squared is negative 1. By definition, that's what it is. Okay, and I cubed then would be I times I squared, which means I times negative 1, so we get negative I. Okay, and then I to the fourth is I squared times I squared, which means I have negative 1 times negative 1. So I to the fourth is 1. So far I have I, negative 1, negative I, 1. Let's look at I to the fifth. Well, I to the fifth isn't the same as I times I to the fourth. And we just said I to the fourth is 1. So this is I times 1, which is I. So I to the fifth kind of gets me back up to where I started. Alright, so actually, is there a pattern here? I, negative 1, negative I, 1. I, negative 1, negative I, 1. Yes, there actually is a pattern. Okay, so the rule of thumb comes from the exponents. And if you notice there's a pattern, and here I have it written out. Okay, so if you take the exponent, divide it by 4, and get a remainder. Okay, so the remainder here shows up right here. And this one we have a remainder of 0. The remainder tells you where in the pattern you fall. If you have a remainder 1 in your power, you get I. If you have a remainder 2 in your power, you have negative 1. And what I mean by that is when you divide by 4, you have a remainder of 2. Then that I to that power is negative 1. If you have a remainder 3, you get negative I. If you have a remainder of 0, you get 1. And so notice, I had I to the first power gave me I to the second power gave me negative 1, I to the third power gave me negative I to the fourth power gave me 1. That's following this exact pattern. I to the fifth, well, the fifth power is 4 times 1 plus 1 at a remainder of 1. So according to my chart here, I should get I, and in fact I did. Alright, let me show you some more examples of this, and hopefully it'll clarify exactly what we're trying to say. Okay, so here in my example, I want to evaluate the following. Part A, I want to find I to the 7th power. Okay, so we need to take 7 and divide it by 4. Right, so if I take 7 and divide by 4, the 4 goes into 1 time, and I get a remainder of 3. What that means is that 7 is the same as 4 times 1 plus 3. Okay, so there it is. There's my exponent. So if you remember from my chart then, that means that I to the 7th has a remainder of 3. 7 has a remainder of 3 when I divide by 4. So I know that this answer is going to be negative I. Okay, now one way you can think about this is think about Wheel of Fortune. If you've ever seen the show Wheel of Fortune, or just think about a clock that only has 4 hours on it. So these hours are 0, 1, 2, and 3. So if the ticker goes around 4 times, it's back to where it started. Okay? So with 7, for example, you start off with 0, and we count up 0, 1, 2, 3, 4, 5, 6, 7. Okay? And you can think of this as 1, I, negative 1, negative I. When I spun my wheel, like in Wheel of Fortune, the thing went around one whole time and then it stopped. Went around one whole time and then it stopped at the negative I spot. Alright, so that's why when you divide it by 4, it shows you, the remainder shows you how many ticks along you gotta stop. Alright, so for example, for 10, we do the same thing. Okay, let's divide by 10, or divide by 4, I'm sorry. That goes into 2 times, which means that my wheel would spin 2 whole times. And then I get a remainder of 2. Okay, so that means that 10 is 4 times 2 plus a remainder of 2. The remainder tells me that this is the same thing. I to the 10th power is the same as I squared, which we know is negative 1. There it is. And so again, if you want to think back to the wheel, that means that I spun my wheel, and I had to go 10 clicks. I spun it, it went all the way around twice, and then it had 2 clicks remaining. Since I had 2 clicks remaining, it ended about right here, it ended here, which means that the powers, I to the 10th power is going to be -1. Alright, let's try I to the 25th. Okay, so I'm going to divide by 4. That'd be a 6, which gives me 24. I get a remainder of 1. Okay, so that gives me my answer, right? I have 25 then is 4 times 6 plus 1. Since I have a remainder of 1, where on my wheel am I? Right there. Okay, this tells me that I to the 25th power is the same as I to the first power, which is just I. Okay, now this strategy works for even high powers. So let's take I to the 116th power, which seems pretty big. So I'm going to divide 116 by 4, and you may have to think about this a little bit. But actually, let's see, 4 goes in 125 times and 16 4. So that'd be 25 plus 4, 29, which actually is 116 even, so I get a remainder of 0, which tells me 116 is the same thing as 4 times 29 plus remainder 0 there. Okay, so that tells me where on my wheel did I spin. I spun it really hard, and it went around 29 times and ended right here with a remainder of 0. So I to the 116th power is the same thing as 1. Some people really pick up on this really quickly. Some people struggle with this a little bit. And if you do struggle with it, that's totally fine, as long as you struggle with it enough to make sense of it. If you have any questions on this, I'd be glad to help. And just as a note, these patterns here we see with these powers of 4 kind of repeating themselves, if that interests you, there's a branch of mathematics called number theory, where people of very high intelligence search for interesting patterns in numbers like this. Again, if you have any questions, I'd be glad to help. Please don't hesitate to ask, and thanks for watching.